Hey, Michael, it's Miss Tracy. So we're looking at the probability stuff after all of the multiple choice questions that you had. So here's the first one. So probability is really just about multiplying fractions, and those fractions represent your desired outcome out of the total number of outcomes that are possible. We just multiply those together. So we're going to determine the probability of flipping a coin 5 times. So the probability that it will land 5 times: heads, tails, tails, heads, heads. These are the outcomes that we want. Now we're going to write the problem to determine what that probability is that if we flip a coin 5 times, it will land in this order. So when we flip a coin, there's only 2 possible outcomes, right? Either heads or tails. Heads is one of those outcomes, so it's 1 out of 2 outcomes. Tails is the other outcome. Tails is 1 out of 2 outcomes. Again, tails, 1 out of 2 outcomes. Heads, 1 out of 2 outcomes. And heads again, 1 out of 2 outcomes. Now all you have to do is multiply. 1 times 1 times 1 times 1 times 1 is 1. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. This is your answer. The probability of flipping a coin 5 times and it landing exactly the way you want it to land is 1 out of 32. So you would type in your fraction, 1 out of 32, and that's correct. All right, next problem. Okay, let's say we roll a die. A die is the thing that you use in Yahtzee, and it's got numbers 1 through 6 on it. It has 6 sides. You might even have one around your house somewhere. We're going to determine the probability that it rolls on a number less than 6. So what are our possible, here's our probability. I'm sorry, less than 5, not less than 6. We want it to be less than 5. So first of all, let's look at all the possible outcomes. It could land on a 1, it could land on a 2, a 3, a 4, a 5, or a 6, right? So all of the options that we want are less than 5. So that's these. There are 4 of them. So we have 4 out of a total of possible 6 outcomes that would be what we would want, right? So there's a possible 4 out of 6 to be less than 5. We can reduce this fraction to 2 over 3. That's your answer. 2 out of 3. Now let's look at the next one. Determine the probability it will first land on 2 and then on a 4 if rolled twice. So the probability that it will land on a 2 and then a 4. So again, we've only got these 6 options. So if there's 6 options, we want it to land on 2. 2 is 1 of the 6 options. 4 is 1 of the 6 options that it could possibly be, right? We multiply. 1 times 1 is 1. 6 times 6 is 36. That's your answer. 1 out of 36. We have a 1 out of 36 chance that it would roll on a 2 and then on a 4. Let's check our work. They're both correct. So let's look at this one. All right, here's the hair bow one. I have 7 blue hair bows in a bag. So let me draw a bag. Here's a cute little bag. Well, maybe not cute. I have 7 blue hair bows. So 7 of these. I'm going to go ahead and draw that. Okay, I got us a little picture going here. I've got 7 blue hair bows, I've got 4 red hair bows, and I've got 5 green hair bows for a total of 16 hair bows. All right, here's our scenario. What is the probability that I will pull out a blue hair bow and then a red hair bow with replacement? This means that I'm going to put the blue one back in before I draw the red one. So if there are 7 blue ones out of 16, right, that's when I pull the blue one. That's my chance of pulling a blue. I have 7 opportunities. I have 7 blue bows out of the total of 16. Now I want to draw a red one. There are 4 red ones out of 16. Right? Okay. So one of the things you want to address is that you can always reduce a fraction whenever you're solving problems. Can't reduce this one because 7 is a prime number. But we know this can be reduced, so we could say 7 over 16 times 1 over 4. That's a lot easier to do the math with, right? 7 times 1 is 7. 16 times 4 is 64. This is your answer. 7 out of 64. So we type that in. 7 out of 64. Okay. Now we look at the next problem. All right, and I've got the same situation. So I'm going to erase my scratch work here so that you want to leave that on your paper, but I'm erasing it so we have room. What is the probability that I will pull out a blue hair bow, then a red hair bow, and a green hair bow without replacement? That means when I pull them out, I'm not going to put them back. So that's going to change the condition or the scenario of my hair bows. So blue, red, green. On the first pull, there's 7, 4, and 5. So for the first pull, I want a blue hair bow. There's 16 total hair bows. I'm going to roll this up just a little bit. There's 16 total hair bows. That's total. So I have a 7 out of 16 chance of pulling a blue. Okay? I'm going to take that one blue away. I'm not putting it back in the bag. So that's going to decrease the amount of blue hair bows in the bag. So now for my second pull, I only have 6 blue hair bows. I still have 4. I still have 5 green. But when I add those up now, I only have 15 hair bows. So that changes my denominator. That changes my number. So now, though, I want to pull a red hair bow. There's 4 red hair bows. So I have a 4 out of 15 chance of pulling a red hair bow. Right? I'm not going to put that red hair bow back. So I'm going to take that red hair bow away. And on my third pull out of that bag, I still have 6 blues, but now I have 3 reds. I still have 5 greens. But now I only have 14 hair bows in the bag. So if I want to pull a green hair bow, I have 5 green hair bows out of a total of 14 hair bows. So 5 out of 14. That's what I have. So I'm going to multiply now. Right? So 7 times 4 times 5 is 140. And 16 times 15 times 14 is 3,360. Right? So I know that I can reduce this, and I think I can reduce this by 20. So let's see if I can do that. So 140 over 3360. 140 divided by 20 is 7. Yeah, that looks good because that's a prime number. And 3360 divided by 20 is 168. All right, so that would be my most reduced because 7 is a prime number. So that would be my solution. 7 over 168. Okay? All right, so now we've done all those calculations. We've seen how it changed our scenario. We've got our third question. Let me erase all of this so that I have room to show you what's going on. Okay. Let me go back over here so we can read the problem. We'll pull it down. What is the probability that I will pull out a blue hair bow? So the probability that I will pull out a blue hair bow and then a yellow hair bow with replacement. That means I'm putting it back in, right? So probability for a blue, there's 7 blue out of 16. So 7 out of 16. How many yellow hair bows do I have? None. There are no yellow hair bows, so that's a 0 out of 16 chance. 7 times 0 is 0. 16 times 16 is a really big number, which we really don't care about because 0 divided by whatever that number is going to be 0. Right? So the answer is 0. There's no chance that you could pull a blue hair bow and a yellow hair bow because there's no yellow hair bows. We honestly didn't even have to do any math on that. We just had to remember what we had. So look for those types of situations. Even though we could pull a probability for blue, we could not pull a probability for yellow because it didn't exist. So therefore the answer was 0. A little bit of a trick question, more of a logic question than a trick question. You were supposed to logic your way out of that one. Anyway, that is the last problem. I hope you kind of get a better understanding of how to do these types of problems in the future. They can be fun when you really get into them and understand what you're doing. So that's all I have. If you have any more questions, please feel free to ask. I'll be happy to help.